I want to welcome everyone to our third Spring Ahead, which is our Shaping Typography program. I'm Gloria Kondrup, and I'm the Executive Director of the Hoffmitz Milken Center for Typography here at ArtCenter College of Design. I'm fascinated with our current speaker, with all of our speakers. I've been fascinated and with our speaker and with our moderator, Roy Tatum. Kyuha Shim, who's our lecturer today, is a designer. I love this, a designer, researcher, and educator based in Pittsburgh. You are an assistant professor at the School of Design and director of Computational Creative Lab at Carnegie Mellon. Q, as you like to be called, works in the interdisciplinary realm of art, design, and technology with a particular interest in the language of systems. Central to your practice is the research and the use of computational thinking as a methodology for design and creating generative systems formed and driven by data. Roy Tatum, who's been our moderator for this series, is a faculty member at ArtCenter College of Design, where he teaches generative type and generative design. Roy also co-founded and serves as creative director at Numbers, a design studio specializing in type design, identity design, and illustration projects. I want to thank you both again for being here. And Q, the stage is yours.
Great, Gloria, thank you for the introduction. So I'm really excited to be here today to meet all of you and talk to you about who I am, what I do, and what really excites me about being a computational designer. So computational design, how did I get here? So my entry into the design field was web design and designing all-flash website using Flash and ActionScript. I was exposed to programming when I was a freshman, which led a smooth transition to motion graphics. Then after finishing my undergrad degree in digital media, I worked as an interaction designer. And mainly I worked on projects focused on kiosk design, digital installations. And till the time I was not that into programming, but data visualization was the biggest motivation for me to learn programming. And my MFA thesis at RISD was on air pollution visualization. And working at Lust in Den Haag, Netherlands was critical to my transition to computational design. And during the time, I wanted to learn more about the field. So I went to MIT Sensible City Lab and worked there for a year. I had the privilege of working with urban planners and statisticians, which helped me to really dive into data analysis and visualization. Then about a year later, I felt that the balance between design and tech in my practice kind of like needed to be recalibrated. So I wanted to take the methodologies in data viz to the broader practice of graphic design. So that's why I went to like Jan van Eyck Academy, which is located in Maastricht, Netherlands, and worked there for a year, focused on exploring like risograph and building experimental rasterization systems. I then moved to London and conducted doctoral research at RCA's Visual Communication Department before I joined the faculty at CMU's School of Design. Okay, so this was a gist of my introduction. And so like, what is computational design? Or what is computation in design? So I would like to start by talking a little about Graphic Magazine's 37th issue, which I guest edited entitled Introduction to Computation. So my aim was to explore computational practices developed by graphic designers. When I began my research in 2014, there was little published work on the topic of computation in the particular context of graphic design practices. So most of the articles and dissertations on computational design were either related to engineering or architecture. Through interviews and surveys, I explored the general attitudes and understandings of computation by graphic design practitioners and researchers, and whether they believed computation can be a graphic design medium beyond the means of production. I was most interested in hearing about their reasons for using computation in their practice and what they thought about the impact of computation on the future of graphic design. Might programming or computational systems be the future of graphic design process? This was one question that I asked all the contributors. Some of them were reluctant to speculate. Like one said, I'm not a futurologist. And another questioned, instead of the future, why not a future? The majority, however, gave me positive responses. We are already living the future. Some said, how could it not be? If the work can be abstracted into an algorithm, it will happen. Another said, programming is no longer future. And some contributors commented that we are experiencing the merge of two disciplines, design and engineering. The last quote reminds me of this one time when somebody asked me, do you see yourself as a designer or programmer? I was able to confidently answer that I'm most definitely a designer and that I see myself as one who utilizes code as a primary medium for creative practice. But at the time, this question really shook me and excited me, because it was then that I realized that there is an opportunity to really develop an understanding of computation as a designer's medium. In doing this research, I took inspiration from the work done by the designers and researchers at MIT Media Lab's Aesthetics Computation Group. John Maeda had been the director of the lab, and he demonstrated that code can be a medium, both process and material, in creative practice by generating visuals through code. So the title of the book on the left is Design by Numbers, and you can see that DBN is highlighted. That's the name of the programming environment that he built, and he used it to create examples that are included in the book. And more importantly, his former students, Ben Fry and Casey Reyes, were inspired by it and made processing, which is a widely used creative coding environment today. Muriel Cooper, she was a book designer and design director of the MIT Press, and then became the founder of the Visible Language Workshop. Again later, she was a co-founder of MIT Media Lab. Since mid-1970s for 2 decades, Cooper's work was largely centered on designing interfaces for designers, using programming languages to create tools for other designers. In contrast to Cooper's time, for Maeda and his students, there were already well-made software tools like Adobe Photoshop, Illustrator, Macromedia Director. So their focus was much more on exploring computational aesthetics and creating interactions between input parameters of various devices and visual parameters of the form. Maeda designed a series of graphics for Morisawa using their logo. Without knowing programming, we can count the number of repetitions per row and kind of guess a sense of automated production there. It looks very infinite. If you're thinking about the process, like who is able to and would want to execute things like these by hand? And like how precisely can we do that? Maeda described that he used PostScript for generating these, and it took a while. But I bet it would have taken much longer if he did it manually. So speed and precision yielded by automation might be one of the most obvious advantages of using code. But there are certainly others. If you're interested in a light reading about how computational design has evolved from Maeda's time to today, I recommend this article, How Computer Code Became a Modern Design Medium by Stinson. Another reference I would recommend is Code as Creative Medium, a book co-authored by my colleagues, Golan Levin and Tiga Brain. Okay, then what is computational design? Considering how things are created, distributed, and interacted through computational media, computational design is becoming increasingly important. When you Google this, there is still a lot of material related to architecture or engineering. Well, first, how do designers use a computer in their practices? It is more than simply using one of the software tools in Adobe Creative Cloud, right? So designers use a computer to create not only artifacts, but also systems. And systems are not just in designers' minds anymore, because they're crafted with code and generate outputs in real time. Maeda defined computational designer as someone who designs products through code, and the products are used by billions of people. So basically, digital designers would build mobile and web applications. He argued the importance of code and data, which I agree, but I would like to focus on what does it do for graphic design and designers. And this is how I would define computational design. There are largely three conditions. First, designers use code to build software. Second, they do this to express their ideas, and they do so algorithmically and parametrically. Third, the computer generates a variety of outcomes. Let's take a look at some examples. So I created a tool using Voronoi and Delaunay triangulation algorithms that enable users to change the values of parameters within the certain ranges that I defined. Within the process, the algorithms determine certain styles, like visual patterns, and the range of parameters set the scope of variations. And these were the outcomes. And I recommended this book earlier, and it's a project that I had contributed to last year. We designed the book with code, and it is the first computationally designed book to be published by the MIT Press. And here, what do I mean by designed computationally? Is the entire book produced automatically? I would say that every page is generated through code, but I left some tasks that require eyeballing by human designers. In that sense, like roughly 95 to 98% of it was produced by machine. And one really interesting thing about this process was defining all the character styles and paragraph styles in design, then using code to load and apply them. So it was very similar to the way we build websites by combining CSS, HTML, and JavaScript. And I mentioned before that automation is the most obvious advantage of using computational process in design. And it indicates a few things about the design process. First, it means that the computer can calculate things tremendously fast. Second, it means that it never makes mistakes. If there is an error, it's on the designers and their logic. Third, the labor for implementing design decision has become like close to zero, like almost nothing. Designers can have more time on shaping their logic and crafting systems. Many designers and researchers recognize that there is a transition in designer roles from making forms to devising formations. What I mean by this is, as designers use code to build their own tools, the relationships between the tools and us designers have become very personal. So the decisions that we make in the process of building tools directly inform our thinking and subsequent decisions. So the process is highly iterative and also reflective. When I talk about my practice, I say that I build systems rather than tools, and that I focus on designing the process of emerging forms, or what I call formation. Beyond automation, computation yields the opportunity to work with variable forms and variations in my practice. In this work, forms are dictated by pseudo-random numbers, which are triggered every few seconds. So it was not about designing a single composition. Rather, it was about designing how variations of compositions emerge. Therefore, I systematically designed the variable patterns, but the details in each variation were somewhat unexpected. Together with unexpectedness, it was my aim to achieve cohesiveness across the variations, so that they're always slightly different from one another, but they still maintain unity because they share the same constraints within which there was a range of freedom. In this case, the outline of letter was constant, while randomly cropped image in each particle, rotation, scale, number of repetition were variables. Randomness can be used as a way to implement a bit of playfulness when generating unpredictable variations. It was like working with freedom in a somewhat controlled manner rather than dealing with pure chaos. An interesting point here is that I instructed my computer to randomly choose colors, and draw a line from randomly distributed points every few seconds. So I knew roughly what kind of patterns I would see in the next few seconds, but I could not foresee the color, shape, and direction of line after a second. And the most compelling aspect of utilizing computation in my practice is the considerations of transformation and variations. Design systems that generate variations within certain visual patterns. In this example, I made a system that gradually enlarged the circles in each color channel and make them travel towards different directions, while the contrast between the circles inside and outside of the text was maintained. So we can see the departure and arrival of the transformation here. Although there is no effect like this in After Effects, but if we assume there is one, we can probably create a structure like this with 2 keyframes with an appropriate filter. The variations can be animated through like endless permutation of values and parameters. Within 64 variations, the program creates the perpetual flow in movement. In addition to the shift in color and position of visual elements, there were variables that randomized speed and interval of the movements. Instead of shuffling within a few options, the variations can be seamless. Unlike the previous 2 projects, the system in this work creates continuously flexible form. So the generated letter forms have different details, but the same look. Additionally, in this project, it was important to check that the outcome always gets more than 30 frames because the final work was generated in real time. Because automation is premised when building computer system, I conceive rules considering the numerical representation and modularity of forms. In this work, I define rules that make modules to transform according to the color values of an image and resolution of grids. I create variations by manipulating parameters, and the algorithms that I write dictate the visual patterns. Using code, I design systems that produce complex, flexible, and myriad forms. In addition to making forms kinetic, computation yields the opportunity to drive data in those variable forms. For example, I designed a digital installation for Graphics RCA 50 exhibition that loads images from an online database So like a play, there was transition between three different scenes where particles are composed with different behaviors or patterns. In another project that was made for International Typography, I wrote a program that creates letter forms using a sequence of imagery data from Google's Street View API. The Street View is such a well-known service, so it was easy to communicate the idea that data can be injected to typography form.
Réalité prise à l'infini, sans sentiment, Vistas.
However, it was difficult to show the real-time aspect in the work. So I added more instructions that distort the letter forms based on the wind data of each city. In this way, we can design formations that are reflective of real-time context. And it is important that designers interpret the context and create interesting relationships between data and form based on that. I was curious how computation may inform typography related to writing and speaking. In this experimental work, I wanted to represent human factors in handwriting. Through computational system, when users write by typing on keyboard. I track the speed and pressure by monitoring the time and gyro sensor when key is pressed and released, and use them as custom input parameters to vary the width and weight of letters. This is the video documentation of the project. And in addition to generating form can be stored as a combination of data.
Spoken word is a generative system. That responds to speech. That responds to speech.
Yeah, so in addition to Performa, the custom typewriter, I made a simple sketch to computationally explore speaking in typography. It was a one-day experiment using speech recognition API, and it repeats letters based on the detected volume of my speech. But as you can see, the result was imperfect. So when designing systems that involve AI, we should embrace unexpectedness. We've looked at some of my inspirations, the seed to my research on computation as a creative designer's medium, and defined computational design, then saw a few examples of its implementation in generative typography. As a last remark, I want to briefly talk about decision-making in designing systems. So one of my heroes, Carl Gerstner, in his designing programs, beautifully described programming from a conceptual standpoint and stressed the active making selections. For Cooper Hewitt's National Design Triennial Beauty, I used this idea to demonstrate that form can be conceived through the choice of parameters. Using computation, parameters become continuously variable, and designers conceive permutable options that can be selected by machine over time. In this way, I'm crafting the pattern of instructions for my computer, which generates form that I imagine. But I wanted to share with you that it is designer's medium that can be used in a variety of ways in graphic design to explore, to experiment, to express, and to experience the way forms are designed and generated systematically. It is a medium and a perspective to seeing artifacts as endlessly variable forms or variations of forms that can drive and store data for giving dynamic, contextually rich, playful, and speculative outcomes. Thank you all for listening, and I'd be happy to answer any questions you may have about anything you just saw, and also about anything you didn't see but want me to address.
Cool. Thanks, Q. Excited to talk more about the ideas presented here and also hear more maybe about your background and experience too. If anyone has questions, feel free to drop them in the Q&A and I can go through them and organize them and then ask them to Q over the course of our discussion. It's really cool that you worked at Lust. They were a big influence for me back when I was in school and first exploring potential intersections of like graphic design and code. I still read through I Read Where I Am from time to time. That book was like, I think the design of that book, which kind of like played with color coding the type by the frequency of appearance of the word in the book, was like, for me, one of the first examples of seeing like how code could be applied to like a graphic design context, which was really cool. I want to talk really quick about the essay that's at the end of Code as Creative Medium, Notes on Computational Book Design. Because I think there was an idea that was presented at the end that I think might be a nice way of kicking off this conversation, where you were talking about that through code, designers' roles are perhaps not diminished, but extended and enhanced because of the shift away from like making one thing to building a system from which many things can kind of emerge. And there's a lot of like discussion about how advances in technology could take work away from designers potentially. Like I think Ellen Lupton in the interview you had in Graphic with her kind of references that. Could you talk a little bit about how specifically the role of the graphic designer might be changing or evolving as a result of computational methods becoming part of the design process?
So I think there are two different perspectives on the impact of computation in terms of like designer roles. So it's gonna, I mean, it can make designers focus on like designing templates for the existing platforms. At the same time, it can allow designers to create another like new systems, new platforms that do not exist, or that I mean, for like new hardware devices, or even for existing devices, it can yield new functions and new mode of like creativity. So designers are not, like as I said in my talk, instead of just making forms, designers are becoming like more focused on designing systems.
Mm-hmm.
And it can be, I mean, there can be designers who build like programming environments or actual plugins, like processing or scriptographer or paper.js or bezel.js, but there can be designers who just use existing programming libraries and express their ideas like computationally by authoring systems for their own work, but at the same time, they can upload their codes on GitHub and other people, and they can inspire other people to continue working on top of like what they already did. Yeah.
Yeah, totally. I thought the point about like automation was really cool too, because I think a lot of times you don't think, like, especially students when they're first working with code, they don't think as much about automation as they do about the aesthetic layer that code is kind of allowing them to explore. So I thought that was like a really cool point too. And perhaps like another way, you know, that designers like practice might evolve too. There's some questions in the Q&A related to like the tools and technologies that you use. I thought it'd be cool to maybe talk about, like, since you mentioned like your first interest in code was through the lens of like data visualization, that was like what got you working with code. I thought it'd be cool just to see like how those tools or programming languages that you've been using have changed over like the course of your practice. Like what were some things that you were using initially, and then maybe to answer some of the questions, like what are tools that you're using now to create your work?
Initially, I started using Flash and ActionScript. And I think that's why I'm comfortable designing like motion or like time-based like graphics using code. And you know, Flash had everything. So like motion and interaction. So and actually it was much easier to produce things that I'm designing today with Flash instead of like processing or P5. But since it's shockwave file is no more like used on Chrome and most of browsers, so I think designers kind of like migrated from Flash to like other like programming languages. Like, and at the time, and when I first did data viz, I used processing, and then for real-time visualization that requires much faster like processing of data, I use open frameworks, and but to at the same time, like I was very interested in teaching code to designers, so I also learned Notebooks, which is a visual programming that does not require scripting at all, which had some limitation. It's based on Python, and it was very easy to walk through the logic because everything was node-based, like Touch Designer, but I'm more like focused on like a 2D graphics. And I also used Scriptographer for teaching a course. And I think similar to Basil.js, it was really influential for graphic design students who were interested in the subject matter, because they were able to see how same things can be authored through like different methods, because they could do it by just using the existing like functions built into tools, but they could also kind of like automate the certain parts which they would never do manually, because it's gonna take a while to do so. And yeah, I think that's kind of like transition of the tools that I've been using. I mean, to be a designer who utilizes code in their practice, the more important part is how one abstracts visual ideas into algorithms rather than like being really an expert in programming. Yeah, because when I see myself and compare my ability to write code to like CS students, like I'm probably like their sophomore or junior level, like because the level of I mean, for designers, programming is, I would say, a lens, especially for computational design, because we are the goal of learning programming is not to become a developer. It's kind of like using it and integrating it with our design practice. Yeah, I use processing for most of my work, and sometimes I use P5, but not for my own work, mostly for teaching. Oh, there's a question related to code as creative medium. For code as creative medium, there are about like 8 to 9 different chapters. And per each chapter, I wrote almost like different scripts. So it's some functions are used again and again, but because the layout was all different per chapter, so I had to write new instructions, and some of the chapters entailed like different amount of information in terms of like hierarchy. So it required me to add more functions. And the coded part, 95%, in Tad's question, when we finalize typesetting, we graphic designers adjust the width of column sometimes and adjust like tracking and like add extra space to like remove like widows and orphans. And initially I tried to do that computationally, but I ran into like a new errors. So I gave up and I decided to leave those work for the last part. Yeah.
Yeah, it seems hard to do. I really liked the framing that you gave where you're saying like the paragraph and type styles in InDesign were like CSS. And you're kind of making the comparison of like, the typical web stack of like HTML, CSS, and JavaScript, and then doing the same thing with Bazel and InDesign. Like that's such a cool way of thinking about it that I think, like I just started teaching Bazel JS in some classes last term, and it's interesting to see like students really start to get excited again about code because it's in that space where like, I think you had also described like part of it can be produced with code and part of it can be like manipulated like directly. And I think like that structure feels really comfortable, I think, for graphic designers, because like you're allowing the code to have like a specific purpose, and you're letting InDesign and like, all graphic designers for the most part have like a certain level of familiarity with InDesign and know exactly like how to work with paragraph and type style. So I thought that was like a really cool workflow too.
Thank you, Ryan.
Like there's another question about how to add emotion or humanity to generative design.
I would say, I don't think I have the answer to that question, but when making the relationship between input and output, from engineer standpoint, it's very much transactional. So when you press button, like you change color, something like that. But for designers, sometimes input and output doesn't have to be like super clear and doesn't have to be like super functional. It can be rather like a emotional, like interpretation of content or context, and assigned related colors based on one's thoughts, right, or concept. So I think there's a lot of room for designers to create humanistic or emotional systems, like through code.
Mhm. Yeah, that's a cool way of thinking about it. It's like, it's not just, there's subtle things in the visual presentation of the work that perhaps add emotion or make it feel human. Also, like the content probably too, depending on the content, like may also be something that you can use to make something feel more human or emotional. Someone's asking if what tool you use for creating the art of selection piece.
Yeah, so I use processing, but it can be made with any tools. It can be done with Python or open frameworks or Java or P5, because I used very basic functions to create the form. So yeah.
Mm-hmm. That's cool.
So when I pop in, it just means that we're close to the end. So just a comment to the question about emotion and humanity aspect of what you do, Q and Roy. Anyone who is a coder and a designer has their own emotion, ethics, choices. So I think the separation from thinking because it's a coding versus a design, it's still the designer and the human that's creating the code, which then imparts a certain amount of humanity and emotional component to whatever design is. Just because the machine is generating it, you as the individual had to tell the machine what to do. So it already encompasses your humanity and emotion and design choices. So I think that's an interesting component that I'm very interested in. I want to thank both of you again, and thank everyone for attending. It's been so interesting, and I'm sure everyone else is fascinated. Just this little tip of the iceberg that we've had here. And again, we're going to deep dive more about this in July and August, about generative and computational design. Thank you, Q. Thank you, Roy. It's been fascinating and extremely interesting, I think, to everyone who's attended. And again, we'll see you everyone next week. So thank you.
Thank you.